Product subarray. Given an integer array nums, find the subarray that has the largest product and return the product. The test cases can be generated so that answer will fit in 32-bit integer. Now, first thing, this is a sum of subarray. What is a subarray? Subarray is nothing but a contiguous part of an array. What is contiguous? A continuous part of an of an array. So this is an array given. What is a contiguous part? 2 and 3 can be contiguous part, or 3 and minus 2 can be contiguous part, or minus 2, 4 can be contiguous part. You cannot say something like this. I mean, I just wanted to show you what is a subarray. So you cannot say this 2 and this 4. This is not a subarray because they are not continuous to each other, or they are not a contiguous part. That's the first thing of the subarray. Now, we have to understand, we have to tell them what is the maximum product. What is the maximum product of this particular subarray? So, how can we calculate with the brute force approach? So, here, if you take this kind of an example, wherein it is 2, 3, minus 2, 4, then simple brute force approach is you have to multiply. This is I and j, right? So, you have to multiply 2 3s are 6. Once this is done, then multiply 3 and minus 2. Once this is done, then multiply 2 into 4. That is 8. No, these all are not possible. Then let's just multiply then let's just multiply this. Let's just multiply this. Let's just multiply in between. That is 3 and minus 2. So all these combinations can be made, which will lead to O of n square complexity, which will lead to O of n square time complexity. What is time complexity? Execution time. It takes a more execution time or more performance time, which we don't want it. Usually, time complexity is the main part for the interview, and we want this sum to be solved in O of n time. So how can we do this in O of n approach in one? Because whatever I showed you right now has nested loops. So it is taking O of n square. So how can we solve in O of n time? There is one Excel which I created to understand this more better. Let's take an example. This is an in nums array. This is a nums array which I have shown you here. Let me mark this. This consists of 2, minus 5, 3, 1, minus 4, 0, 10, minus 10 to 8. These are the numbers of the number array. Now we have to find exactly the same thing, maximum product of subarray. That is the contiguous part of the subarray, which has maximum product, not a subarray, but a maximum product. That is what we have to find out. Usually, if you see, if an array consists of negative integers, right, there are two things to understand over here is, if you can also ask to your interviewer, if there are negative numbers, then the product will become, it will flip the product. Whatever is the positive, right? If you got a result as a positive integer, and immediately if there is a next integer is negative, then your result will become negative. So it will flip your answer. So we have to take care of these negative integers. First thing first. Second thing is we have to take care of zero number, because zero will completely change the result. It will completely restart your numbering. So these 2 points should be taken care of. How to take care of these 2 points? These are the formulas by which we can take care of negative and zero numbers. And that's the reason I gave a array which consists of negative numbers as well as the zero numbers. Here in this case, we need these four main variables, and these are the formula. Let me show you. Current is always a nums of I, like wherever we are, that becomes our current. And mean so far is the minimum minimum of these two products, that is the current and mean so far into cur and max so far into cur. So these are the three numbers. Let's see one by one. These are the three numbers we are going to check the mean of these three numbers. That is the minimum of current, minimum of current and product of mean so far into current and product of max so far into current. And what is max so far? Same thing, just write the max over here. Max of current and mean so far into current and max so far into current. Let's see how to do this. Suppose this is an array which is given. Suppose this is an array which is given. So first thing, when we are entering for this formula, we are going to initialize all these four variables as nums of 0. This is nums of 0, right? This is 0th index. So I'm going to initialize with all as 2 because it is nums of 0. Then I'm going to start with a for loop because we need to find out the result. We need to find out this particular result, right? So as far as now, the result is nums of 0, which is 2. Then let's go ahead. What is next? The for loop will start from -5. That is, for loop will start from index 1. So what is mean so far? Mean so far, as I showed you in the formula, blue is the formula written. In the formula, it is mean of current. What is current then? -5, because current is nums of I. Whatever is the index is the current. So mean is -5 and product of what? Mean so far and current. What is mean so far? Here, previous, check the previous mean so far, okay? So the previous mean so far was 2. So the product of 2 into -5 and then previous max so far and -5 is the current. See here, the formula, check in the blue line, it mean of current, that is -5, then previous mean so far. What is previous mean so far? 2 into -5, that is current. And previous max so far, which is also 2 into current. And then take the minimum of them. If you see, the minimum is -10. Next, same thing do for max so far. Max of current, as seen in the blue chart, the formula is written max of current. So what is over here the current? -5. Previous mean so far, again it is 2 multiplied by -5, which is current. Then again previous max so far into -5, which is current. So if you take the max of this, it is -5. Do we need to update the result? Because result previously was 2. We don't have to update the result because if you see this -10 and -5, there is nothing maximum in that. So we are not updating the result and we are keeping the result as it is. Next, we will go to the next index, that is the index number 2, which has value of 3. So the current becomes 3. And if you do this formula in the blue, same as I repeated in the first time, same formula, if you repeat it, then the mean so far becomes -30 and max so far becomes 3. So here I'm going to update my result with the max so far because earlier result was 2. And what is the maximum? Maximum is 3. So I'm going to update my result. Let's go to next. The index number is 3. In this index number, current value is 1. So when there is a 1 current value, again we are calculating with the formula mean so far and max so far, and we are not updating our result because it is 3 only. If you see the next index, that is the fourth index, 0, 1, 2, 3, 4. Yeah, fourth index, the value is negative. So whenever there are negative numbers, it will definitely flip the result, right? That's the reason we are taking care of that. And that's the reason we have this max so far and mean so far. So if you observe, when there is -4, see the current value, mean we are finding the current of -4. We are finding the minimum of current, then the product of mean so far and current, and max so far and current, which gives us minus 12. And at the end, we are finding max so far, which is 120. If you see 120 is the largest, so we are updating our result as 120. Now, next index, fifth index, if you carefully observe, it is zero, right? Which will turn the gain. And we have to take care of that. That's the reason we have initialize result also, which will store our results and which will not hamper our result. That's why we have this particular result as a initializing variable over here. And also we have this formula which will help us to avoid the flip flop of our result. So here now the current is zero. If you do min so far and max so far, obviously it will become zero, but we are not going to update the result because we need the max product so far, and max product so far is 120. Next, if you see the current, it is again negative number. Again, it should not hamper our result. That's the reason. If you see, if you calculate with the help of the formula, mean so far and max so far are not greater than our result. So we are not updating the result. Same thing if you go to the next, that is a positive number. So we are good. It is two, a current number or an index is two, not index, the value is two. So when value is 2, it will calculate mean so far and max so far. Again, it's not greater than the result. We are not updating the result. Same thing with the next value. It is current value is 8. So we are calculating mean so far and max so far, but they are not greater than the result. So our result becomes 120, and our answer of this particular array, maximum product sub array, is 120. Maximum product sub array is 120. So basically, if you see, if you use this formula, mean so far and max so far, these particular two formulas, this will help you in finding your maximum product sub array. And this won't, you don't have to repeat the for loops again and again to finding the product subarray. Basically, it won't take O of n square time complexity. Execution time will be less, that is O of n time, because it just has it has just to it just have to go through entire array once, not twice. It just going entire array once, so there is no nested for loops. And result again is initialized. This variable is very important because we store the result, and it doesn't hamper even if there is a zero numbers or negative numbers. And min so far and max so far is also taking care of zeros and negative, because we are multiplying and then taking the minimum out of it and maximum out of it. That's the reason this algorithm is useful. This kind of algorithm is useful for O of n time complexity. Space wise, it is O of 1, because there is no space, there are no nothing data structure we are initializing. It is just the variables which we are initializing. So let's start coding. And so far a max product subarray, and we have given the nums array. So max so far, let's initialize to nums of 0 as shown in the diagram, and mean so far also will initialize to nums of 0, and result will initialize to 0. Now we'll start a loop as shown in the diagram. I'm starting the loop from 1 because we are using nums of 0 over here. So we have to start from the next index. I is less than nums dot length, I plus plus, and then I'm initializing current value, which is at nums of I, that is at the initial index, that is 1. And then I'm also initializing one temp variable just to make the things easier. There is no change in our formula. The formula is same. So we are checking max of her into math dot max of mean so far into cur and max so far into cur. Then mean so far is equal to math dot mean. And then you can just copy this. This is the same thing that we are just putting the minimum over here. We are just checking the minimum so far over here. And then we are updating our temp so far to max so far. So for max so far, we are updating the temp so far. And in the result variable, we are again checking the maximum, whatever the maximum result is there, that we are going to give it to the result variable. Whatever the maximum product is there, that we are giving it to the result variable and returning the result. That's it. I mean, this is the formula which I showed you in the Excel sheet. These are the formulas which we are using, by which we are solving, and we are iterating only once in the follow. Only I'm taking temps so far just to make the things easy, and I'm again assigning this temp so far to max so far, so that I can use this max so far to check, to compare with my result, and whichever is the greatest maximum product subarray, that we are returning in the form of a result. And time complexity O of n, space complexity O of 1. Thank you.